Good morning, everyone. Today I'll be presenting Milestone 1 of the Aethermart semester project for the subject Advanced Data Management Systems. So, the agenda or the roadmap for the presentation is like we'll begin with an overview of the project, then we'll move into our MariaDB setup, then database schema design, followed by data generation. And from there, I'll walk you through data ingestion, advanced SQL implementations, and some data cleaning techniques that we used while making the project. And so at the end, we'll talk about some AI and the conclusion of the project. So basically, the problem statement was that Aethermart was actually facing a major issue with inconsistent product, customer, and order data. This led to unreliable reports, delays, and high risks of errors. For example, mismatched names and prices in smart home devices, right? So basically, the impact was clear. There were inefficient operations, poor data quality, and weak security controls. So our objective was to build a robust relational database management infrastructure and apply some foundational data practices and leverage SQL for data preparation and security. So as you see that the key challenges here were everything was manual, so error-prone data entry was there. Then customer and order records were fragmented. Then there were some scalability issues with the supplier onboarding. And at the end, it's weak access control. So basically, security was hampered and there were some compliance risks. Now, to address these, we expect a centralized, reliable system and a standardized and clean data to basically support future milestones. So these are the key tasks that I performed in this project. So it started with the environment setup, then I did the schema design, then data ingestion, then used some advanced SQL like developing views, developed virtual columns, stored procedures, and some user-defined functions, that is UDFs. And at the end, I cleaned the data and did some enforced some role-based permissions so that security is enhanced. And all these things will result in these expected outcomes that I've mentioned here. So to begin with, this was the script that was given to us by Dr. G, and I extensively used this in the daily instance build-up. So earlier we used to do it manually, then we generated our own scripts, and then this script is a kind of a foolproof script that works every time, I believe. So this setup actually ensures reliability by updating the system automatically, and it created a .sources file itself, and it uses automation to guarantee consistent and error-free installation of MariaDB every time, right? So I use the script to build the MariaDB and install the MariaDB, and as you can see that MariaDB is installed. Now I move to the database schema design. So it covers all the tables that were given to us. So like products, categories, suppliers, customers, then orders, order reviews, and order items. So basically, I created the database in the beginning, and then ensure that whenever the SQL script is run, it drops the database if it exists, so that if any table exists already in the database, it will also get dropped. So whenever we'll run the script, it will work. So yeah, as you can see that the tables are generated, but there is no data, right? Because we didn't ingest any data yet. Now there is this part where we generate data using the Python script that again was provided to us. Then I was getting some error that the Faker module was not installed, so I chat GPT'd again, and it suggested me it gave me some commands to install the module and just run the script. So after running the script, we see that the data is ingested, and if you can see here, some data is there in the three tables, and here it's a script that I use to get this output. So basically, it tells me the count of data or rows in every table we have, and also there is there are some commands mentioned to see that what's the count of some rows where emails is missing, and what are the rows where rating is invalid. So these all these stuff will help us in cleaning our data in the later slides, right? So this was the data ingestion part. Now we also implemented some advanced SQL features like views, virtual columns, procedures, and UDFs. So this is a part of view. Basically, it simplifies some complex queries, and if we wish to grant a limited access maybe to some people, their views are useful. And basically, instead of just writing a long query every time, we can just create a view and query it directly. So it lets us like hide the complexity and acts as a data abstraction kind of thing. So here, if you see that create view is the command we use to create a view, and it acts as a normal table only. So we just fetch the data from a view using the simple select query. So basically, it doesn't store data itself, but instead it pulls data from the tables whenever we query it. So we can think of it as a window to our data, right? So if you see here, this was a view, and we queried it just like a normal table, like select star from. But it's actually not a table; it's a view, right? Now the next thing is a virtual column. So we can use this as a method to calculate some columns or fields. Like there is no need to initially make that column while making the schema, but um, at any point of time, if we feel that there is a need of an additional column where we need to perform some sort of calculation or we need to put some logic, then we can use this virtual column. So this is the command alter table add column, and if you see that I've added a total price column, and this is visible in the bottom query, like select order item ID, quantity, etc., from order items. So if I query this table, right, I see this additional table form that is total price, which is actually what it is actually the total price that we calculated from multiplying the quantity with the price per unit, right? So this is not something that we initially provided in the database creation, but we felt that there is a need to fetch total price also. So that's why we created this virtual column, and we gave it a formula that is quantity into price per unit, right? So it calculated the price accordingly and put the values in the total price column. Now, the third thing is stored procedures. So again, procedures is a sequence of queries. We can store this sequence of queries in form of procedures, and we can call the procedures again and again instead of writing all the queries, right? So it's like a function, a normal function we make while coding. So if you see here, I have created a procedure called get customer orders, where like we're simply fetching the customer orders and its details. So once this procedure is created, we can call the procedure using the command called call. So if I just enter a command like call and then followed by the name of the procedure, then I will get the response as if I entered all the SQL query I wrote inside that procedure. So basically, it makes our job a lot easier. Now, there is one last thing, that is UDF. So UDF is basically user-defined functions. So again, these are used to extend some SQL logic, right? So here, if you see that I have created a function called is valid ratings, which validates if the rating is valid or not, and it returns a boolean. So UDF again is a kind of function we make in SQL to make a job easier. So there's no need to, again and again query. We can call this function, and we can put into it some kind of logic which we need to perform. So for example, here it is like fetching the data um, according to the rating. So if the rating is invalid, it is giving us a valid flag as 0 or 1, right? So basically, that's the point of UDFs, that we can make a function, we can put in some logic, and then we can call the function accordingly. Then comes the data cleaning part, right? So our like my cleaning was divided into three parts. So the first one is that there were some missing values in the field of email IDs when I checked the data. So what I did was I simply replaced the email IDs with a default value of an email ID, as you can see here. So I just queried it to find the entries where email ID is not there, and then I simply updated it with a default value so that it doesn't give problem going ahead. Then the next part was invalid ratings, right? So wherever I found ratings to be invalid, that is where ratings are not between 1 to 5. There, what I did was um, so basically we deleted those ratings, right? For example, here if you see the command that is delete from reviews where rating not in this. So if I again query it, I'll find that there is no entry where review is invalid. So all the invalid entries with invalid reviews were deleted. Now, so the third part of data cleaning was duplicate suppliers. So the data was inconsistent, as we discussed earlier, right? And there were some entries which were duplicate. So there's a small query. So basically, what this query does is that it it's like a self join, right? So there are two references to the same table, basically S1 and S2, and there's a condition that it looks for the rows which have the same supplier name. that means that the entry is duplicate, right? So to ensure that, um, so basically we're deleting the duplicate entries, and how we're deleting is that, for example, there are two entries who are duplicate. So we are deleting the entry with a higher ID. So the statement, right, s1.supplier id greater than s.supplier id, this ensures that if there is one entry that is duplicate, the one with the higher ID will be deleted. So we need to do this because we need some sort of criteria in how to delete duplicate entries. So here I use this criteria to delete the duplicate entries. Then coming to security. So security was a key focus for this project, right? And um, we like ensured security based on permissions. Like we gave some role-based permissions which limited access based on responsibilities. For example, here if you see, I've created a role that is analyst, and this analyst is only has a permission to fetch data because we have granted only select permission to this user. Okay. Then there is this data entry user. Now, data entry user has an access to insert and update in our database, right? And there is this third user also. Um, okay. So if you see here, I try to insert some data into the DB, and it says that insert command denied to user data select, right? Because we didn't give access to this user to insert or update the data, right? And in the same way, if you see that, similarly, we didn't give the same user an access to drop some table. So it again says that drop command is denied to user for table this. So this is how we like grant permissions to our users. So if I provided a select um, permission to the user, it will only be able to fetch data and not update, delete, or insert. And similarly, if I provide an access to a user to delete the data and nothing else, then it will not be able to do anything else. So that was it about the security part. And now the AI talk. So I use ChatGPT for scripting, for some SQL fixes, like just to for getting some SQL syntax right. And if I'm getting some error, I used ChatGPT to do that. And also I used it to explain me some part of the code. For example, the duplicate part, right, where we need to delete duplicate entries. So I asked that to ChatGPT that explain me this part. Then um, ChatGPT was used to, like, as I said, correct syntax and then automation steps, and also explain me stuff and enhance my clarity on content. Um, so basically, using AI was definitely helpful. It provided me the speed, the clarity, and the support that was needed. But it's not always that the AI was right. It always needed either a better prompt or some kind of change in the answer or the solution we got from AI. So overall, it enhanced the efficiency and understanding while like highlighting both benefits and limits of relying on AI. So yeah, AI was used extensively, but AI was not completely being relied on because I am sure that it's not 100% right. So yeah, thank you.